G'day guys, we've got an applications of differentiation question today where we've been asked to produce a sketch of this cubic function, and we've got to include the location of any stationary points, any points on the graph where the function cuts the vertical or horizontal axis, and we've got to indicate the behaviour of the function or the graph as x approaches positive or negative infinity. So what I'd like to do first, guys, is before I start differentiating or anything like that, I want to find the roots or the x-intercepts of this function. So first of all, I'm going to rewrite our function down here. We've got f of x is equal to 3x squared minus x cubed. Cool. Now what I'm going to first do is I'm going to factorize this. So this is going to be equal to x squared outside of 3 minus x. And we're going to use our null factor law because we've got to make this, the function at x-intercepts has to equal 0. So we can see here that either x squared is going to be equal to 0 or 3 minus x is going to be equal to 0. So we can say that from here, either x is going to be equal to 0 or x is going to be equal to 3. And the coordinate points that we get from here is we're going to get 0, 0 and 3, 0. Great, so that's the first step on the way to graphing this function. We can put these 2 points in if we like. We have 0, 0, which is here, and 3, 0, which is here. Great. So let's get on to the next part where we have to differentiate this function. So we're going to find the differential, so f dash of x, and this is equal to 6x minus 3x squared, which, if we're trying to find where this function is equal to 0, we want to factorize it. So we're going to have 3x outside of 2 minus x. Now at the turning points or the stationary points, the derivative or the first derivative is equal to 0. So what we're going to do from here, guys, is we can use the null factor law just like we used here to say that either x is going to be equal to 0 or x is going to be equal to 2. Now, we know that the coordinate point when x is equal to 0 is just 0. So what we're going to do is we're going to figure out what the function equals when x equals 2. So we're going to enter 2 into our original function, not the derivative, and we're going to get 3 times 2 squared, which is 3 times 4 is 12, minus 2 to the power of 3 is 8, which is equal to 4. So we have a stationary point at 2, 4 and 0, 0. Great. So let's put that point in, 2, 4. And we know we've got a stationary point here. So the next thing I like to do, guys, is I like to have, before I even start these kind of questions, a rough idea of what my function is going to look like. So we have a negative cubic function here, and so a negative cubic is one that takes this sort of shape. So you can see that this turning point here will correspond with this turning point here will correspond with this, and it's going to look somewhat like that. So this, I would say, is one of the more important things when you're in exams, is to have a rough idea of what the function is going to take the shape of. So we know a positive cubic, if we were to write all these down, would look like this. It would go up, but we're left with a negative cubic, and as a result, it goes down. Cool. So we know that we've got a turning point here. This is going to be a local minimum. We know we've got a local maximum up here. And we know we're going to have to cut through this point down here. Now, you'll have to forgive me. Trying to draw these graphs on a computer is very, very difficult. Okay, good. So what we would probably do after this is we would label our turning points. So we would label this as 2, 4. And we would label this as 0, 0. We would, if you wanted to, you could label this piece as 3, 0. But you need to, finally, to finish this question off, we have to indicate the behavior of the graph as x approaches positive or negative infinity. So we know for a negative cubic, we can write this down. As x approaches negative infinity, you can see that as we go this way, y is going to approach positive infinity. And as x approaches positive infinity, this way, y is going to approach negative infinity. So you can see that if we had a positive cubic, it would be exactly the opposite. We would have, as x approaches negative infinity, y would approach negative infinity. As x approaches positive infinity, y would approach positive infinity, much like a linear, positive linear function. So guys, let me just run through what I did again, just before we go, and to make everything as clear as possible. To start with, what I did is I found my x-intercepts by factorizing the function, setting it equal to 0, and then using the null factor law to solve it. After that, what I did is I then differentiated my function, factorized it again, set it equal to 0, so I could use the null factor law to solve that for x. Of the coordinate points that I didn't already know, that namely this x equals 2 here, I substituted that back into the original function so I could figure out what the corresponding y value was, i.e. 4. Once I did that, I plotted all these points that I've found. I then figured out what the negative cubic function looked like, found the corresponding local and maxes and minimums, and after that I was able to try on the computer to draw it by hand. So I hope the video helped, guys. If it did, give it a thumbs up. Subscribe to my channel. I put out new videos all the time. But if you have any problems with this video or videos like this, be sure to leave them in the comments section below. I'm always looking for new video ideas, and your comments really, really help get the ideas flowing. So other than that, guys, the only way to get better at these kind of maths is to practice, practice, practice. As long as you keep banging your head against the wall will eventually fall down. But whilst you're doing all that, guys, remember to keep enjoying yourself, keep enjoying your maths. Until next time, I'll see you soon.